I am good morning for everyone. I am from Embedded System Laboratory at University of Badji, Mokhtar, Annaba. I will present my topic entitled Correlation Analysis of Visual Imaginary EEG Signals in Different Frequency Bands. To present our topic, we will begin with a general introduction, and we will present materials and methods, and we will show the results and the discussion, and finally we will end by conclusion. Our topic concerns brain-computer interface-based EEG devices, which is a field that supports and assists challenged individuals. BCE devices communicate directly to user attention by just decoding brain signals, in our case, EEG signals. In EEG signals, the major challenge in BCE system is the complexity nature of brain signals, which make it difficult to interpret and analyze this type of signals. There are two main types of BCE system, motor imaginary and visual imaginary system. In motor imaginary, the subjects requires to imagine certain parts of their body moving, while in visual imaginary, the user have to visualize mentally thinking or an action. In our topic or in our work, we will focus in the second type, visual imaginary. We have collected our data while users or subjects visualize the action of lighting on the room for about 60 seconds and lighting of the room for also about 60 seconds. Here is an example of the record from one user while completing the task of thinking about the two imagination tasks. We are collecting data from 22 subjects were in good health, male and female. The age of all subjects fell into the age group of 19 to 22 years. All subjects were students. We have used the NeuroSky headset to collect data. This tool displays the EEG brain signals in 8 frequency bands, which is delta, theta, alpha 1, alpha 2, beta 1, beta 2, gamma 1, and gamma 2. It displays also the brain signals in the raw data. To extract relevant information from our dataset, we have calculated the following filters: mean, standard deviation, and variance from all the 22 recorded signals. We have used also the correlation coefficient, which is the most widely used index to measure the degree of a linear relationship. It varies from -1 through 1. The EEG dataset was measured by Pearson's correlation coefficient just to find the linear association between filter pairs and to identify the most filters that represent our data. Of course, in different EEG frequency subbands. We have used the MATLAB tool to calculate our results, and we, as shown in this table, the most significant value was of correlation index was in the beta frequency, and the highest level of the index correlation was 0.977 in the beta frequency. And as shown graphically, the most important two filters pair that represent that have the most highly correlation index was mean and standard deviation, as shown here. This is the second graphic that represented the imagination task 2, and the main important two filters pairs was mean and standard deviations values that have the highest correlations value. We conclude from our study that the most significant frequency band was beta frequency, in which our imaginary task, the imagination of lighting on and lighting off the room, has occurred. And the best filters to represent our data was mean and standard deviations filters. This conclusion or this results will help us to filter and classify our data set. Thank you for your attention. Here are some references that we have used in our presentation.